Hey there, this is Andrea with my week one advanced interactive concept for the gummy bears in a hypertonic and hypotonic solution. What I'm going to do is show what happened with the gummy bears after sitting them in two different solutions of water. Um, okay, so what I did here was I have the results from my gummy bears sitting overnight. And as you can see, here's the original gummy bear. Let me see if I get it here. Okay. It's made out of pretty much gelatin and sugar. There is water used when it's first being made. However, most of the water evaporates, and so you're pretty much just left over with gelatin and sugar and food dye. And then here is the water only solution that I soaked the gummy bears in. So these were soaked for like 10 hours overnight. And as you can see, they're a lot larger, very, very mushy, almost like jelly. And that is because they took on the water. Over here, I have the salt and water solution that I let the gummy bears sit in for the same amount of time, about 10 hours. And as you can see, they're a little bit smaller than the original, whereas this water only solution is double the size, maybe more on this one. And then over here, it's it's a little bit smaller, but it's really not, you can't tell that much. It just looks like it lost a little bit of weight, but it's essentially the same size. It's not very much taller or anything like that, or shorter. And so what happened with that is the process of osmosis occurred with the gummy bears, and in two different ways. So with the ones that are bigger, the one that was in the water only solution, the hypotonic solution, because the gummy bear is semi-permeable, meaning that it'll accept molecules across its membrane. It took on the water, going from a lower concentration to a higher concentration. So the water was able to penetrate the membrane, and it wanted to pretty much go where the water molecules weren't. So through osmosis, it went from the water only solution to inside the gummy bears. So for the saltwater solution, the gummy bears are just a little bit smaller, and that's because in making the gummy bears, when they use the water to form it into the mold, it gets cooled, and that's when the water evaporates. And so there's not really much water left over through the process. And so, but there was a little bit, obviously, in these gummy bears because they shrank. So the water was trying to go from the gummy bear to the saltwater solution, because that's the way the osmosis wants to dry it, is because of that concentration of salt and water. The gelatin is a long chain molecule, so it's not going to accept the salt from the water. So there's a difference in the permeability of it. When the gummy bears that were in the water, okay, lost my train of thought there for a second. But the gummy bears that are in the water, they also kind of lost their shape because they took on so much water. So you can't really tell the difference. It just looks like a blob that was put into there. There's only a little bit of shape. This one completely just looks like a blob of jelly. And you can see that there are like characteristics on these bears, and there's really not over here. And so, over here, sorry. So the concentration is obviously a lot higher with the salt water, because the salt was not the salt was just too much of a barrier between the membrane and the makeup of the gummy bear. So because it was trying to create equilibrium between osmosis, that is why you have the bigger mass of the hypotonic solution and the similar yet smaller mass of the gummy bear in the saltwater solution.